Hello, if you've been following these tutorials so far, we have created two what if usage scenarios, one with solar and one without. And when we compare them, we can see that there's significant savings to be made by adding solar. Once I've added the solar though, I'll be curious to know what happens if I add a battery. So in order to add a battery, I'll copy my solar PV and then I'll edit it. So the first thing I'll do is I'll give it a better name, solar PV, comma, battery. And I'll save that off. Now, when I have this done, I can go into my battery options, which gives me two options. I can create settings or schedule. If I try to create a schedule, it'll tell me that I don't have any settings in place, so I have to define it. So I will do that. I'll add my settings. When I add my settings, I get a battery edit screen. There are no batteries defined, so I can use the button in the bottom right to create a new battery. It has to be connected to an inverter. We have only one inverter. I'm going to double the size of this and say 10.9. Whoops, missed my point. That'll be important. Discharge stop in terms of percentage is absolutely fine. It's around 20%. The maximum discharge in 5 minutes, you need to maybe do a little bit of math from what's actually provided by your battery vendor. The batteries I'm looking at discharge at a little bit under 0.5 C. That's half their capacity in an hour. So in this case, I'm going to go to 0.45, both charge and discharge. It's a pretty good battery, 0.45. My storage loss is basically down to the fact that I have chemicals in my battery and they are not perfect in terms of their to and from chemical storage to electricity. So there's always a bit of a loss there. The charge rate, there's three of them here. I've incorporated the BMS and the battery together. So the BMS, the battery management system, is there to protect the battery, to ensure that it doesn't damage itself, that we don't charge it too quickly or too when it's near full charge or when it's near empty. So this gives us three different charge rates, 0 to 12%, 12 to 90%, and 90 to 100%. And then this percentage relates to the maximum charge. So between 12 and 90%, it will actually charge or discharge at 0.45. Beyond that, it actually slows down quite significantly in order to ensure the battery doesn't damage itself or isn't damaged. So that's effectively it to actually set up a battery. You have to attach it to an inverter, give it a size in kilowatt hours, indicate where you want it to stop charging, define its characteristics. This simple view of a battery doesn't have any time-based derating. It's just based on percentage of charge, which is the charge rate in the charge model down here. So I can save this off, and then when I go back to my main what if usage scenario, it will well, in this case, it didn't simulate directly. So if you want to trigger a simulation directly, you need to tweak any of the parameters here. So if I just edit the load profile and then save the load profile, it'll trigger that as a change. And you can see down at the bottom that the simulation happened. So once that's happened, I fell into the big trap here. There is no sun up in the solar panels. You need to remember, and I need to remember, that you need to define the solar PV. So once I edit the solar PV, I can fetch up the data. This is already downloaded. It tells me this, so I can just download and save that. It finishes doing that. I go back, I get my bar chart, I go to my second set of panels, I fetch and update this data, and it should only take a moment and I'm good to go. I can save this off and go back and leave this, and now I'm getting a simulation happening and I can see what's happened. So the cost has gone down, my best cost. If I come out of this, I can now look at my comparison and I can see my solar battery has actually saved me another, saved me another €300 in this particular plan. If I look at it, I can see that I've reduced my usage at the higher rates. And if I go into my usage, I can also see that I have started to send some of my PV directly to the battery. I've also improved my self-consumption and my self-sufficiency because I'm able to better make use of my generated solar electricity. Now, for me, the savings here weren't as good as I would have hoped because the repayment time on 300 euros worth of saving for a battery are, they're okay. But if I chose a better plan, then the savings are, whoops, why did I still have this plan. If I chose a different plan, the savings are actually considerably less, so 120 euro, depending on the plan you get. So the plan that you choose has a significant bearing on the amount of savings that you make with the battery. In the next video, we'll show you how to actually make better utilization of the battery and what a difference that can make. Thank you for listening.